While some countries are still working tirelessly on their sixth-generation fighter projects, and many are just starting to figure out the complexities of fifth-generation aircraft, the United States has once again asserted its dominance in the field of military aviation. The U.S. is venturing into the uncharted territory of seventh-generation fighters. This is an audacious move that has left the world watching with bated breath. As we progress, we're going to peel back the layers of secrecy and explore the details of this creation that has redefined the boundaries of aerial combat. We'll delve into the technology, the capabilities, and the implications of this seventh-generation marvel. Join us as we uncover the truth about how the USA is testing its new seventh-generation fighter jet that shocked Russia and China. In the pursuit of creating the sixth-generation fighter, developers encountered a fascinating development. They discovered that there are two distinct approaches for deploying fighter aircraft in the warfare of the future. What made this discovery even more remarkable was that it was driven by a neural network suggestion. However, they soon encountered a challenge. The integration of multidirectional characteristics into a single aircraft proved impossible. Consequently, the Next Generation Air Dominance, or NGAD program, expanded to include a second project, the development of a 7T8 generation fighter. It's important to note that the idea of aircraft generations is relatively new. It wasn't until Lockheed Martin used the term fifth generation to describe its F-35 that this classification system gained traction. Older aircraft were then retroactively categorized into the generations that best fit their characteristics. For example, the F-4 became a third-generation aircraft, and the Eurofighter was labeled as a fourth-generation aircraft. It started as a marketing gimmick but has now become widely accepted. The U.S. Air Force has also broken down the capabilities of these generational designations. Second-generation aircraft featured swept wings, range-finding radar, and infrared-guided missiles. Third-generation aircraft introduced supersonic flight, pulse radar, and beyond visual range missiles. Fourth-generation planes added agility, sensor fusion, pulse Doppler radar, reduced radar signatures, fly-by-wire, and look-down, shoot-down missiles. Fifth-generation aircraft then incorporated stealth, advanced sensor fusion, and supercruise capabilities. As the development of the sixth-generation stealth fighter continues, the U.S. Air Force is already setting its sights on the future with the pursuit of a seventh-generation stealth fighter jet. This forward-thinking approach highlights the Pentagon's commitment to pushing the boundaries of aviation technology. The development of each new generation of fighter aircraft is known to build upon the achievements of the previous ones, pushing the envelope of what's possible in aerial warfare. With the seventh-generation stealth fighter on the horizon, we can anticipate even more cutting-edge capabilities and advancements in aviation technology. It's, however, expected that aircraft from the sixth and seventh generations will emerge simultaneously. So, what exactly will the seventh-generation fighter be like? And how did the United States manage to make such significant strides in new aircraft development, while Russia and China are grappling with engine development for their fifth-generation fighters? At this juncture, the United States, Japan, Great Britain, Germany, and France are actively engaged in the development of sixth-generation aircraft, with the United States leading the pack in terms of progress. Under a shroud of heightened secrecy, prototype flight tests for the promising sixth-generation fighter have been conducted, although serial production is yet to commence. The B-21 Raider, currently in development, is one of those. It's a project that draws inspiration from the successes of the B-2 Spirit. Both of these aircraft share a distinctive flying wing design, signifying a logical progression in the evolution of stealth bomber technology. Similarly, when we examine the realm of fighter aircraft, most sixth-generation designs have followed a similar pattern. Its full capabilities may not be disclosed for some time. Nevertheless, it represents a significant step forward in the field of stealth bomber technology and underscores the U.S. military's commitment to staying at the forefront of aviation innovation. Meanwhile, the development of the seventh-generation fighter is also in full swing already. The American NGAD program is currently in the developmental phase. The next step, the Initial Operational Capability, or IOC phase, will commence once production facilities for components are established and an assembly shop is set up. The most crucial and challenging stage, which involves the development of key technologies for the new fighter, has already been successfully navigated. At this stage, a remarkable technological breakthrough has paved the way for the rapid creation of aircraft, almost 10 times faster than the development of the F-22 or F-35. This breakthrough centers around the extensive use of artificial intelligence throughout the aircraft creation process, from conceptualization and mission definition to simulating real air battles. Remarkably, it's not military generals, but a neural network-based artificial intelligence that has taken the lead in defining the objectives for this project. AI appears to possess a more refined understanding of the warfare of the future and the required combat characteristics of fighter jets. It has accelerated development in the most challenging stages, which historically consumed 90% of the project's time. Importantly, AI can simultaneously consider multiple aircraft concepts, a task beyond the capacity of human engineers and designers. In addition to strategic and tactical tasks, artificial intelligence is also adept at simulating the aircraft's structure and power plant, subsequently predicting the aircraft's performance in the air. What's more, the neural network, through the use of reality modeling, facilitates the testing of these future aircraft by pilots. Crucially, AI doesn't merely design aircraft in isolation. It takes into account the current state of technological advancements and the availability of new materials and alloys. In the NGAD program, human involvement primarily consists of rapidly feeding diverse data to the neural network. High-ranking military officials are primarily tasked with evaluating the results. This innovative approach results in the simultaneous creation of fighters from the 6th and 7th generations, a groundbreaking development in itself. Fighter jets of the future will have the capacity to carry high-energy laser weaponry. Right now, developers are working with laser installations that are somewhat underpowered. That's why various missile types, including hypersonic ones, are currently the main armament. However, the fighter must be designed to accommodate laser weapons for future upgrades easily. These fighters also have a variable cycle engine with specialized adaptive technology. Lockheed and Aerojet Rocketdyne have been pioneers in this domain, crafting a combined cycle propulsion system that's quite the marvel. This system uses a turbojet engine when speeds are below Mach 3 and seamlessly transitions to a ramjet engine for hypersonic flight. It starts up and generates thrust by ingesting air at high speeds. The real beauty here is that it employs the same air intakes and exhaust nozzles for both turbojet and ramjet modes, eliminating the need to make any mid-flight alterations to the aircraft's initial configuration. Another remarkable facet of modern fighter aircraft is the integration of unmanned control systems. The absence of a human pilot in the cockpit bestows several advantages. It enables the aircraft to operate in hypersonic flight modes, expanding its maneuvering capabilities significantly. Some of these maneuvers subject the aircraft to astonishing levels of G-forces, far beyond what the human body can endure. The absence of a cockpit also creates space for the installation of effective cooling systems, crucial for components and units that experience high thermal stresses. When considering these crucial qualities in the context of a 7th-generation fighter, a different perspective emerges. The primary arena for its application would be near space, bordering the effectiveness of even the most advanced air defense systems, such as Russia's formidable S-500. This system is effective up to altitudes of approximately 124 miles above sea level, a range that a 7th-generation fighter could potentially reach. In this context, flight altitude and superspeed become more pivotal than traditional stealth characteristics. Hypersonic speed, a hallmark of the 7th generation, suggests a unique design. It's conceivable that this aircraft's aesthetics might draw inspiration from George Lucas's iconic T-65 X-Wing space fighters from Star Wars. However, it's essential to note that the new aircraft will predominantly operate within atmospheric conditions, with occasional forays into near space. Therefore, the aircraft's structure must withstand the mechanical and thermal rigors of such maneuvers. The aerodynamic design of the 7th-generation fighter will be tailored for hypersonic flight, incorporating materials like heat-resistant steel alloys, titanium, ceramics, and composites. The aircraft will feature swept wings and volumetric air intakes, with payload integration inside the aerodynamic fuselage to minimize additional heating during hypersonic flight. This configuration will enable the 7th-generation fighter to execute lightning-fast strikes against high-priority targets, with the potential to traverse the Atlantic Ocean in approximately 1 hour. The flight envelope of the 7th-generation fighter encompasses subsonic, supersonic, and hypersonic ranges, bridging the gap between the legendary SR-71 Blackbird and the conceptual Lockheed SR-72. This transition is made possible by a combined cycle power plant initially developed for the SR-72 by Lockheed Martin and Aerojet Rocketdyne. Traditional turbojet engines fall short in achieving hypersonic speeds, and a single ramjet engine requires a starting acceleration, necessitating a combined approach. Lockheed Martin's Skunk Works division has provided some intriguing insights into the SR-72 program, which aims to create a worthy successor to the iconic SR-71 Blackbird reconnaissance aircraft. The Advanced Aircraft Development Division of Lockheed Martin has shared with Aviation Week that hypersonic technologies, including a combined cycle propulsion system uniting a supersonic jet engine with a rocket engine, have progressed to a stage where earnest work on the SR-72 can commence. On paper, the SR-72 is set to be a formidable strike and reconnaissance aircraft, capable of reaching speeds exceeding Mach 6. This development is not just exciting from a military standpoint. It also has implications for civilian aviation. The United States Air Force has awarded a substantial contract to a startup specializing in high-speed aviation to create reusable hypersonic aircraft. If this project proves successful, it could potentially revolutionize commercial air travel, offering passengers much faster journeys. From a military perspective, the SR-72's capabilities hold strategic importance. With speeds exceeding Mach 6, it could offer rapid response and reconnaissance capabilities that are unparalleled. It has the potential to change the dynamics of modern warfare, enabling quicker deployment of forces and more timely intelligence gathering. In an era where speed and agility are critical, the SR-72 represents a significant leap forward in aerospace technology. Furthermore, the fact that hypersonic technology is now seen as having dual-use applications, suitable for both civilian and military purposes, underscores its versatility and potential impact. While the military applications are undoubtedly impressive, the prospect of hypersonic civilian air travel is equally exciting. It could redefine how we think about long-distance journeys, making the world feel smaller and more accessible than ever before. Given the punishing speeds of hypersonic flight, though, human piloting becomes impractical. Therefore, this intelligent fighter will be exclusively controlled remotely, particularly during hypersonic flight in an autonomous, unmanned mode. The nature of hypersonic flight severely limits radio communication with ground operators. Hence, an autopilot and an onboard combat control system will shoulder the responsibility of managing the aircraft and executing combat missions. To facilitate coordinated actions at tactical and operational levels, the onboard system of the 7th-generation fighter will be integrated with Link 16, a tactical data exchange network that connects various participants in combat operations, including satellites, warships, submarines, drones, artillery, and aviation assets. This comprehensive network enhances the fighter's situational awareness and coordination abilities, ensuring its effectiveness in the dynamic and interconnected theater of modern warfare. Now let's delve into the question of suitable weaponry for the 7th-generation fighter. It's evident that conventional bombs and missiles, the staples of the U.S. Air Force arsenal, aren't tailored for near-space operations. Therefore, the focus of developers must shift toward energy weapons. These advanced armaments will redefine the fighter's role, with primary targets including enemy satellites and strategically vital ground assets. A powerful laser mounted on this aircraft will be capable of disabling nuclear power plants and reactors. It becomes a formidable tool in the arsenal. Moreover, we can't discount the utility of hypersonic missiles in this context. The 7th-generation fighter might serve as the launch platform for such projectiles. Notably, these rockets wouldn't require a booster engine, resulting in a more compact and cost-effective solution. It's worth noting that the complexity and sophistication of the 7th-generation fighter will inevitably inflate its cost, likely exceeding that of its 6th-generation counterpart by several $100 million per unit. In this realm, the United States stands alone as the world's sole military superpower with the financial clout to undertake such ventures. It's essential to remind critics of substantial military budgets that not all nations align themselves as U.S. allies. For many countries, it's the United States' formidable military capabilities that serve as a deterrent against aggression. This unique position, held by the U.S., underscores the importance of maintaining a robust defense. Reflecting on history, the United States holds the distinction of being the first nation to produce a 5th-generation fighter, exemplified by the legendary Lockheed Martin F-22 Raptor, which entered service as far back as 2005. The American aerospace industry successfully established serial production of such advanced aircraft. What's even more remarkable is that the United States is the sole country globally operating two distinct types of 5th-generation fighters, the F-22 Raptor and the F-35 Lightning II. The latter is even more widespread and massive in scale. Presently, these American 5th-generation fighters face no direct competition. While Russia boasts the promising Sukhoi Su-57, it remains a work in progress, with only one unit operational and two others undergoing testing. The primary bottleneck hindering serial production is the unavailability of a suitable engine. China, too, has made strides in 5th-generation fighter development, exemplified by the Chengdu J-20, with approximately 150 units built. and the Shenyang J-31 undergoing flight testing. However, both Russian and Chinese developers grapple with engine-related challenges. It's worth emphasizing that these limitations aren't permanent. Sooner or later, Russia and China will overcome these obstacles and join the League of Nations with formidable fifth-generation fighter capabilities. However, it may take a while for them to meet up with the U.S. standard. The United States is even pursuing expanding the operational envelope of the SR-72 as the relevance of space operations becomes increasingly apparent. Fighter jets equipped with the capability to venture into low Earth orbit open up a realm of new missions, including satellite maintenance and space situational awareness. Yet, this audacious leap into the cosmos comes with its own unique set of challenges, particularly when it comes to re-entry into Earth's atmosphere. Successfully navigating this new frontier requires a keen focus on thermal protection measures. Ensuring the integrity and survivability of fighter jets during the fiery descent back to Earth is of paramount importance, representing yet another technological frontier that must be conquered. Looking ahead, the synergy between advanced drone capabilities and the exploration of space operations paints a thrilling picture of fighter jets evolving into multifaceted platforms that transcend terrestrial boundaries. They are poised to become instruments not only of war, but also of exploration, protection, and innovation. The breakthroughs on the horizon hold the promise of taking fighter aircraft capabilities to unprecedented heights. We're entering an era where adaptability and versatility will become the defining features of air superiority. Some still do not understand what it takes for an aircraft to exceed Mach 5. For an aircraft to cruise through the skies at Mach 5 and beyond, it necessitates an airframe constructed from advanced heat-resistant materials. Think about materials like carbon nanotubes, ceramic matrix composites, or refractory metal alloys, all meticulously engineered to withstand the blistering temperatures and intense pressures experienced during hypersonic flight within Earth's atmosphere. Furthermore, the contours of these aircraft would feature sleek, stealthy designs optimized for hypersonic aerodynamics while simultaneously addressing infrared and radar signatures. Moreover, the advent of hypersonic missiles and drones directed from these aircraft could completely transform the dynamics of strategic warfare. Targets located thousands of miles away could be struck in under an hour, introducing a new level of precision and agility in military operations. To become a space-capable fighter, aircraft must undergo substantial redesign to meet the unique challenges of low Earth orbit. The airframe, for example, needs robust thermal protection to withstand the blistering heat generated during atmospheric re-entry at orbital velocities. Materials like niobium alloys and carbon-carbon composites emerge as key players in ensuring the aircraft's safety during these demanding maneuvers. Now let's shift our focus from the depths of space to the cutting-edge world of directed energy weapons, or DEWs. Integrating high-power lasers and other DEWs into future fighters has the potential to revolutionize air combat. Recent advancements in solid-state laser technology have paved the way for viable DEWs for aircraft use. Powerful fiber or diode lasers compact enough to seamlessly integrate into seventh-generation jets, boasting capacities measured in multiple kilowatts. These lasers may offer tactical capabilities that far surpass those of conventional missiles and guns. DEWs, particularly lasers, come with several distinct advantages over traditional ammunition. As electronic weapons, they eliminate the need for costly physical projectiles and reloading, thereby drastically reducing logistical burdens. Moreover, laser beams travel at the speed of light, providing faster engagement capabilities than conventional missiles. The versatility of these weapons shines through as they can serve both offensive and defensive purposes. They're capable of delivering precision strikes against incoming missiles, drones, or enemy aircraft while simultaneously neutralizing surface-to-air missile sites and other ground targets that were once out of reach. This expanded operational radius significantly enhances the fighter's survivability, making it a formidable force in the evolving landscape of modern warfare. As the global landscape evolves, the United States maintains its edge in aerial warfare. The development and deployment of 6th and 7th generation fighters are paramount in preserving the military advantage that the U.S. holds, and its strategic foresight is essential to safeguarding national security interests in an ever-changing world. Thanks for watching. If you enjoyed this video, click on the link appearing on your screen to check out another of our interesting videos. See you there.